The roof system of a structure is a very important aspect of a building. From a design perspective, it plays a big role in defining the character of the building's form. Typically, a roof's design complexity will directly correlate to its complexity of assembly, ultimately affecting schedule. Because a roof is the first line of defense from weather, completing its assembly is a critical milestone in the construction process. For these reasons, it's important to understand the general makeup of a roof's framing structure. So with this in mind, we're going to look at the two methods of framing a pitched roof, which is the most common type of roof used in light frame construction. So let's take a look at the first method, which involves using individual sticks of lumber to frame up the entire roof system on the project site. The process starts with installation of joists after the top floor walls have been completed. This will permanently tie the walls together and also provide the support for the attic space floor decking. Now, just as with wall framing, the decking acts as a stable base for the carpenters to work from when framing the roof. Once the decking has been installed on the joists, the superstructure for the roof can begin, and this starts with the installation of the ridge beam. Now, obviously the ridge beam is not going to float in midair the way I'm showing it. So, what do the carpenters do to deal with this? Well, they build a temporary scaffold system to support the beam until it's permanently tied in. This will also act as a work platform for the carpenters when tying in the rest of the framing members. So the ridge beam acts as the central tie-in point for the rafters, and the rafters will define the roof slope and provide support for the roof sheathing, ultimately the base that the roof membrane will sit on. Each rafter is individually installed until the entire roof system is completed. Once framed, the decking can be installed, and in this case, because we're using a gable roof system as an example, the gable ends can then be framed up. So while this is a repetitive process, you can see how it's very labor intensive as well. Which brings us to method number 2 for framing a roof. Roof trusses are pre-manufactured framing members designed by a structural engineer and built in a factory. Because they are made in a controlled environment using manufacturing equipment, a higher level of quality and consistency can be maintained. They're designed in various different sizes, shapes, and load carrying capacities. However, regardless of the profile, all trusses have the same elements to their makeup. So let's look at the parts for a minute. All trusses will incorporate a top chord, a bottom chord, and a web. Now, while the parts of the web will vary from one design to another, they will all have a web, as it is inherent to the truss's structural integrity. In other words, what I'm trying to say is, without the web, the truss would just fall apart. So, how does this prefabrication design impact the process on the site? Well, once completed, the trusses are shipped to the project site fully assembled and ready for installation. Typically, the members will be hoisted onto the walls of the building either with a crane or a forklift type machine called a lull. However, a more common practice for smaller buildings where the trusses are not so heavy is to place them on the bearing walls in an inverted fashion, and then a couple of men will rotate them up into place and secure them. Regardless of the hoisting method, once the trusses are on top of the bearing walls, they can be set into place on their centers, which would typically be 24 inches on center, and temporarily braced across the top chord until the permanent bracing can be put into place as dictated by the design engineer. The roof sheathing can then be installed with the membrane to follow. So the efficiencies of using trusses in this application are pretty clear. But what are the factors that affect which type of system we should use for a particular application? There's basically 3 elements to consider here: time, cost, and quality. Okay, so time being how is a particular method going to impact the overall completion of the project, and in the majority of cases, trusses typically win in this aspect over stick framed. And then you have quality. Again, trusses are the leader here because you have more quality control with it being a factory environment that they're being manufactured in. So what about cost? Well, there's two aspects of cost. There's material cost and labor cost. From the aspect of material cost, stick framing is typically more economical because the cost of the direct material to stick frame a roof is less than what you buy a manufactured truss for. But then you have labor cost. So how does labor cost work? Well, in the examples that we've seen in this video, using a truss roof system is dramatically cheaper from a labor perspective. But labor is a function of project complexity. Now, what do I mean by that? Well, let's go back to our model that we looked at here. And let's say that we add a little bit of complexity to our roof system by putting a dormer in our roof. Now we have some intersecting roofs that are increasing the overall complexity of our design. So if we go back to our evaluation metric, what we're going to find is by the project complexity increasing, the labor cost is going to be directly affected because there's going to be more time spent in the field to assemble the product. And it doesn't matter whether it's a truss roof or a stick frame roof, there's still more time to assemble these multiple roofs together and make them one complete system. And in fact, with a truss roof, it becomes more complicated than a stick frame roof. So now what we find is in the cost of labor, stick framing wins over truss framing. The other aspect to consider here is the material cost. Again, we mentioned before that typically stick framing is more efficient from a direct material cost than truss framing, and when the complexity of the roof increases, when you have multiple sizes of trusses, the material cost goes up even more for a truss roof. So once again, material cost becomes an even larger factor of efficiency for stick framing over truss framing. As you can see, there's no clear cut and dried answers to which method is the most appropriate, and being able to evaluate each project effectively to determine the appropriate application is critical to a successful project.